Hello everyone. Today we are going to understand the structure of Bicyclo and Spiro compounds. Let us take one example. Here there are two rings. Bicyclo compounds have two fused rings, okay, with the help of a bridge. So this is one ring, CH2, and there is one more ring, CH2, CH2, and this one. There are two carbon atoms which are common to both the rings. These are called bridgeheads. Bridgeheads. These two are the bridgeheads. Okay. So, and these are the bridges. This is bridge of two carbon atom. This is bridge of one carbon atom, and this is again bridge of two carbon atom. Okay. I'm repeating. Bicyclo compounds are those in which two fused rings are present and with the help of bridges. There are two carbon atoms which are common to both the rings which are called bridgeheads. And each bond or chain of atoms connecting the bridgeheads are called bridges. Okay. So while naming bicyclo, first we have to write bicyclo. Okay, I'm talking about those bicyclo compounds in which there are no substituents present. So while naming bicycloalkanes, first write the prefix bicyclo. Then in the square bracket, we have to write the number of carbons in every bridge in descending order. So 2 here, 2 in this bridge, and 1 in this bridge. So it will be 2 dot 2 dot 1. So the number of carbons of each bridge we have to show in descending order separated by a full stop. And at the end, you will write the name of the alkane, count the total number of the carbon atoms present in the compound, and the corresponding alkane will be written. Heptane. There are total 7 carbons, so it will be heptane. Let us take another example. It looks little, sometimes they show in a complicated manner, but it is a simple one only. Suppose it is this one. Here it seems that it is connected here at this particular point, but it is not. Okay, so because there are straight lines, so it is not connected here. It is the straight chain. So these two are the bridgeheads, and there are 3 carbons in this bridge, 2 carbons in this bridge, and 2 carbons in this bridge. This can be shown something like this. 2 bridgeheads you show like this, then like this. So this is one bridge with 2 bridgeheads, and then this is the second bridge, and then this is the third bridge. 2 bridges have 2 carbons, 2, 2, and this one has 3 carbons. So it will be bicyclo 3, 2, 2. And there are total carbons 9. No name. Clear, people? Next, what if there are substituents present? Then we have to number each bridge starting with bridgehead. For example, this one, CH, CH2, CH2, CH, CH2, 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 C, and in the middle one, there is one substituent. This is the substituent. These two are the bridgeheads, this one and this one. So if substituents are present, we have to number the ring system starting from the bridgehead which is closer to the substituent. So both are at equivalent position, both bridgeheads with respect to this. So 1, carbon number 1. Then we have to go along the longest bridge. So the longest bridge is this one, which has 3 carbons, 1, 2, 3. So this will be carbon number 2. This is 3. This is 4. and we reach to the next bridgehead atom like this, and then we have to go to these, go along the second longest chain. This is 6, this is 7, and at the end, the smallest one. So now the substituent methyl is present on 8th carbon. So it will be 8-methyl bicyclo, again square bracket, and then you will mention the number of carbons in each bridge in descending order: 3, 2, 1, octane. There are total 8 carbons, right? I'm taking one more example. Suppose you have functional groups such as ketone in the bridges, something like this. This is having one ketonic group, this is having another ketonic group. Okay. Now there are two bridges are similar, this one and this one. This is one bridgehead, this is another bridgehead. So, and these two ketonic groups are at equivalent position from this bridgehead. They're closer to this. So this bridgehead will be given carbon number 1. Now I can go along this left hand side bridge or this rightmost bridge, because both of them are having same number of carbon and the same functional group. So this will be carbon number 1, this is 2, this is 3, go to the another bridgehead, 5, 4, 5, 6, then reach to the first bridge, and then 7, 8, right? So this is some alkanon, but here there are two ketonic groups present, so it will be alkane dione. We have to mention the position of the ketonic groups while naming. So since for this functional group we use suffix, so the name will start from prefix bicyclo. Total number of carbon in each bridge is 2 only, 2, 2, 2. Then total carbon numbers 8, octane, 2, 6, dione. Here, on is the suffix for the functional group, but we are using before that di. So that's why this alkane's E is not removed. Okay, so it will be bicyclo 2, 2, 2, octane 2, 6, dione. Now coming to the Spiro compounds. So in bicyclo compounds, we saw that there are two bridgehead atoms. In Spiro compounds, there are two rings joined by one 4-degree carbon or quaternary carbon. So there is a 4-degree carbon which is common to two rings. For example, in this case, this one is the 4-degree carbon. This is also called spirocarbon in this particular compound. Okay. Now for naming, you have to start first numbering from that carbon which is next to the spirocarbon and present in the smaller ring. So there are two rings. This ring is of 3 carbons and this ring is of 5 carbons. So this one is this one will be given. This is next to the carbon. So this one, either you can give this also 1, 2, or you can give this also 1, 2, and then you have to reach to the quaternary carbon, which is spirocarbon 3. Then you can go like this: 4, 5, 6, 7. Okay. So while naming, we use prefix spiro, and then in square bracket we have to write the number of carbons in each ring in ascending order. There in bicyclo compounds it was in descending order. Here it is in ascending order. So the name will be spiro 2, 4, heptane. Right? Let us take another example. If you have substituent, okay, then also irrespective of the length of the irrespective of the nature of the substituent, we have to take always the smallest ring first. This is the spirocarbon. So here, suppose there is ethyl group present. So this is the spirocarbon, the middle one, okay, quaternary carbon. Next to that, this carbon is there and this carbon is there. So I will prefer this one because the substituent gets the least number. Okay, 1, 2, 3, then 4, 5, 6, 7, 8. Let us attach one more group. Suppose here there is bromine present. Okay, so since for bromine, B comes first in alphabetical order, then E for ethyl. Still, we have chosen this because this is the smaller ring. So, but when you write the name, then you have to consider the alphabetical order. 5 bromo, 1 ethyl, spiro, 2 5 octane, right? So you please remember, irrespective of the nature of the substituent, okay, while numbering we do not consider the alphabetical order of the substituent, but when you name it then you follow the alphabetical order. Okay, let us take one more example. This is having one unsaturated bond as well. Suppose here is ethyl and there is a double bond here. So again, in this case also, this is the spirocarbon, and I said that irrespective of the nature of substituent and irrespective of the position of double bond or triple bond, always first number the smaller ring. So this will be carbon number 1, 2, 3. In the smaller ring, you can follow at lowest locant rule. So 3. Then now since we have reached to this ring, try to give the doubly bonded carbon the least number. So you will go through this line: 5, 4, 5, 6, 7, 8. Suppose there is one methyl group is also present. Okay. So its name will be 1 ethyl. You have to go in the alphabetical order. Ethyl will come first, then methyl, 4 methyl, spiro, 2, 5, oct, 5, E. Yes, people? I hope you understood well now, and there is no confusion in spiro and bicyclo compounds and their nomenclature. Thank you. Bye.